when an elevator circuit breaker trips when running on generator power, especially during leveling, there are several potential causes to investigate. Firstly, consider voltage drop during leveling. The elevator motor draws high current when leveling, causing a significant voltage drop in the system. The SCR controls may be sensitive to this voltage drop and tripping the circuit breaker. Secondly, look at insufficient generator capacity. The generator may be undersized or not providing enough power to handle the elevator load. Thirdly, check for loose or corroded connections. Poor connections at the elevator control or other points in the electrical system can contribute to voltage drop and circuit breaker tripping. Fourthly, a faulty elevator motor may be the culprit. The motor may be experiencing insulation breakdown or other issues that cause excessive current draw. Fifthly, damage to the SCR controls can lead to problems. Improper installation or aging of the SCR controls can lead to premature failure and circuit breaker tripping. To troubleshoot this issue, follow these steps. Firstly, confirm the voltage drop. Accurately measure the voltage drop at the elevator controller when the elevator is leveling. Compare it to the manufacturer's specifications. Secondly, check the generator capacity. Ensure that the generator is capable of providing sufficient power for the elevator. Thirdly, inspect connections. Inspect all electrical connections in the elevator system, including the controller, motor, and generator. Tighten loose connections and replace any damaged or corroded components. Fourthly, load test the elevator. This will determine if the elevator is operating within its rated capacity and identify any potential overloading. Fifthly, inspect the elevator motor. If voltage drop and connection issues are not the cause, consider inspecting the elevator motor for insulation breakdown or other electrical faults. Sixthly, check the SCR controls. Ensure that the SCR controls are properly installed and not experiencing any faults. If necessary, have a qualified technician inspect and diagnose the controls. Also consider these additional tips. Consult the elevator manufacturer's specifications for allowable voltage drop and circuit breaker settings. Maintain proper battery backup for the elevator to prevent power outages during generator operation. Regular load testing and maintenance of the elevator system is crucial for its proper operation. If the problem persists, consider contacting a reputable elevator maintenance company for further troubleshooting and repair. The voltage drop can be measured using a multimeter. Place the multimeter probes at the input terminals of the elevator controller while the elevator is leveling. Record the voltage reading. Compare this reading with the voltage reading when the elevator is not leveling. The difference between the two readings is the voltage drop. To assess generator capacity, check the generator's nameplate for its kilowatt or kilovolt ampere rating. Compare this rating to the elevator's power requirements, which should be available in the elevator's documentation or on the elevator motor's nameplate. Ensure the generator's capacity exceeds the elevator's power needs with some margin for other building loads. To check electrical connections, visually inspect all connections at the elevator controller, motor, generator, and any intermediate junction boxes. Look for signs of corrosion, looseness, or damage. Use a wrench or screwdriver to tighten any loose connections. If corrosion is present, clean the connections with a wire brush or replace the corroded components. A load test involves operating the elevator with a known weight inside the car. This test verifies that the elevator can handle its rated load safely and efficiently. During the load test, monitor the elevator's performance, including its speed, acceleration, and deceleration. Also, observe the electrical system for any signs of overheating or excessive voltage drop. To inspect the elevator motor, use an insulation resistance tester, also known as a megameter, to check the motor's insulation. Disconnect the motor from the electrical system and connect the megameter leads to the motor windings and the motor frame. The megameter will apply a high voltage to the insulation and measure the resistance. A low resistance reading indicates insulation breakdown. Also, visually inspect the motor windings for any signs of damage, such as discoloration, cracking, or melting. To check the SCR controls, visually inspect the SCR modules for any signs of damage, such as burn marks, cracks, or loose connections. Use a multimeter to check the voltage and current at the SCR terminals. Compare these readings to the manufacturer's specifications. If the readings are outside the specified range, the SCR controls may be faulty. If the SCR controls have adjustable settings such as firing angle or current limit, verify that these settings are properly configured. Incorrect settings can cause the SCR controls to malfunction. When inspecting connections, pay close attention to the grounding connections. A poor ground connection can cause voltage fluctuations and contribute to circuit breaker tripping. Verify that the grounding conductors are properly sized and securely connected to the grounding electrode system. In addition to load testing, consider performing a no-load test on the elevator. This test involves operating the elevator with an empty car. The no-load test can help identify mechanical issues such as excessive friction or binding that may be contributing to the problem. During the no-load test, monitor the elevator's speed, acceleration, and deceleration. Also, listen for any unusual noises, such as squealing or grinding. If the elevator exhibits poor performance or unusual noises during the no-load test, it may indicate a mechanical problem. When inspecting the elevator motor, check the motor's bearings for signs of wear or damage. Worn or damaged bearings can cause the motor to draw excessive current and contribute to circuit breaker tripping. To check the bearings, listen for any unusual noises, such as rumbling or clicking. Also, feel the motor housing for excessive vibration. If the bearings are worn or damaged, they should be replaced by a qualified technician. When inspecting the SCR controls, check the cooling system for proper operation. SCR controls generate heat during operation, and a malfunctioning cooling system can cause the SCR to overheat and fail. Verify that the cooling fans are running and that the heat sinks are clean and free of obstructions. If the cooling system is not functioning properly, it should be repaired or replaced by a qualified technician. When measuring voltage drop, use a true root mean square multimeter to ensure accurate readings. A true root mean square multimeter is designed to accurately measure alternating current voltages, even when the waveform is distorted. A standard multimeter may not provide accurate readings when the waveform is distorted, which can occur when the elevator motor is operating. When checking generator capacity, consider the inrush current of the elevator motor. The inrush current is the surge of current that the motor draws when it starts. The generator must be able to handle the inrush current without experiencing a significant voltage drop. The inrush current can be several times the motor's normal running current. When inspecting connections, use an infrared thermometer to check for hot spots. Hot spots indicate areas of high resistance, which can cause voltage drop and contribute to circuit breaker tripping. Aim the infrared thermometer at the connections and look for temperature readings that are significantly higher than the surrounding area. If hot spots are found, the connection should be tightened or replaced. When load testing the elevator, use a calibrated load cell to accurately measure the weight in the car. A load cell is a device that measures force or weight. Using a calibrated load cell ensures that the elevator is being tested with the correct weight. When inspecting the elevator motor, check the commutator and brushes for wear and damage. The commutator and brushes are responsible for transferring electrical current to the motor windings. Worn or damaged commutator and brushes can cause the motor to draw excessive current and contribute to circuit breaker tripping. To check the commutator and brushes, visually inspect them for signs of wear, such as grooves, pitting, or carbon buildup. If the commutator and brushes are worn or damaged, they should be replaced by a qualified technician. When inspecting the SCR controls, check the gate drive circuitry for proper operation. The gate drive circuitry is responsible for controlling the firing of the SCR. A malfunctioning gate drive circuit can cause the SCR to fire improperly, which can lead to circuit breaker tripping. The gate drive circuitry can be tested using an oscilloscope. The oscilloscope will display the voltage and current waveforms at the gate terminals of the SCR. Compare these waveforms to the manufacturer's specifications. If the waveforms are not within the specified range, the gate drive circuitry may be faulty. When measuring voltage drop, measure the voltage at multiple points in the elevator circuit to identify the source of the voltage drop. Measure the voltage at the generator terminals, the elevator controller input terminals, and the elevator motor terminals. Compare these voltage readings to determine where the voltage drop is occurring. When checking generator capacity, consider the power factor of the elevator motor. The power factor is a measure of how efficiently the motor uses electrical power. A low power factor can cause the generator to be overloaded, even if the motor is not drawing excessive current. The power factor can be improved by installing power factor correction capacitors. When inspecting connections, use a torque wrench to ensure that the connections are tightened to the proper torque. The proper torque value is specified by the manufacturer. Over-tightening or under-tightening the connections can cause them to fail. When load testing the elevator, monitor the temperature of the elevator motor and SCR controls. Excessive temperature can indicate that the motor or SCR controls are being overloaded. Use an infrared thermometer to monitor the temperature of the motor and SCR controls. If the temperature exceeds the manufacturer's specifications, the elevator may need to be derated or the load may need to be reduced. When inspecting the elevator motor, check the motor windings for shorts to ground. A short to ground occurs when the insulation on the motor windings fails and the windings come into contact with the motor frame. A short to ground can cause a large current to flow, which can trip the circuit breaker. To check for shorts to ground, use an insulation resistance tester, also known as a megometer. Disconnect the motor from the electrical system and connect the megometer leads to the motor windings and the motor frame. The megometer will apply a high voltage to the insulation and measure the resistance. A low resistance reading indicates a short to ground. When inspecting the SCR controls, check the snubber circuits for proper operation. Snubber circuits are used to protect the SCR from voltage transients. A malfunctioning snubber circuit can cause the SCR to fail. The snubber circuits can be tested using an oscilloscope. The oscilloscope will display the voltage and current waveforms across the snubber circuits. Compare these waveforms to the manufacturer's specifications. If the waveforms are not within the specified range, the snubber circuits may be faulty. Remember to consult the elevator's specific documentation for detailed troubleshooting procedures and safety precautions. Always prioritize safety when working with electrical equipment. If you are not comfortable working with electricity, it is best to call a qualified technician. By systematically investigating these potential causes and following the troubleshooting steps, you can effectively diagnose and resolve the issue of an elevator circuit breaker tripping when running on generator power. Always refer to the manufacturer's documentation for specific instructions and safety guidelines.